I would say if we finish tomorrow, I would say quiz Thursday
Okay.
on
So
18
it's
to
not
20.
tomorrow.
Correct.
Okay.
Yeah, because that was under the estimation of when we were finishing things last week. I just like to try to put up a tentative date, but I'll fix it later. As I was making plans for this week, I was like, yeah, it's not going to be that. I just haven't gone over there to change all the dates for everything yet, from things shifting and all that. So, which Thursday is, they're handing out the Valentine's, so we should be fine because they're not going to come in here with just two of you in here. They're going to do it when you're all together,
Probably
or when at least
first
most of your
period.
classes together, either second or sixth probably,
Do you
just
think
because they've got to get the
No,
little
everybody
kids
will be,
first
right?
hour.
'Cause-
Yeah.
Yeah.
Or they might not get y'all till first hour on Friday because that's sometimes what ends up happening.
Do you think there's singing and giving out stuff in the same period?
Yeah, they're doing two groups, but I think each group is singing and handing out stuff. So, but they usually have to get the little kids first because they have a bunch of them that leave half day. So,
Yeah.
but I don't know. I haven't been told yet exactly what's happening. So,
Who knows?
anyways,
I had a lot of fun doing that. It wasn't actually that bad.
Wait, why are they doing on Thursday? What's happening?
because the basketball teams are leaving at like 12 on Friday,
Where are
and
they going?
pretty much half the juniors play basketball, so they couldn't really do it. They're going to Broadwater. So, and the first game's at like 4 or 4:30, so they have to get over there.
Yeah.
So, or they're leaving by 1, I think, and you can't do it during lunch, so it's like, yeah, it's just this whole thing. So, all right. Someone hands you a box of a dozen chocolate-covered candies. How fitting that it's almost Valentine's Day. They tell you that half are vanilla creams and the other half are peanut butter. Okay, so I want the peanut butter.
Yeah.
Okay.
And then
You pick candies at random and discover the first 3 you eat are all vanilla.
It's a nightmare, bro.
Yeah.
Tragedy.
Although at least you get the ones out of the way you don't like first.
True.
So if there really were 6 vanilla and 6 peanut butter candies in the box, what is the probability that you would have picked 3 vanillas in a row? So this is a little bit of a throwback
That's
to when we were doing probability. So what's the probability that the first one is vanilla?
Would it be like
a
0.5?
Yeah, so
And
I'm
then
going to do it
times
as
by five.
fractions first because that's just the first candy. So obviously, we're not eating it and putting it back in the box. We're eating it in its entirety. So the
Dude,
first
that'd be
one
nasty. That'd
would be 6 out of 12. What's the probability that the second one is vanilla?
That's 36 out of. Wait.
We took one away.
Oh, 5 out of 12?
We took one away.
7 out of 12?
No, we took
Wait.
one away. 5 out of
11.
5 out of 11.
I was like, where are you getting 36 from?
So I was like, what?
I was like multiplying the. I don't know.
So again, I didn't bite it and put it back in the box. I just ate it. So then what's the probability that the third one is also vanilla?
4 out of 10.
4 out of 10.
See, I was halfway there. I was good for 12.
So this is 120 out of 1,320, which is 0.091, and that's rounded. So this is the p-value. And I would just note that it's not too low. I mean, that's almost 10% chance, so that's not too bad.
So this still technically works then?
For the moment, yes.
Okay.
So do you think there really might have been 6 of each of them?
Yeah.
So, I mean, I think there's a good chance of it. I mean,
Unless
it.
they lied to us.
Well, you also have to think. Okay, it says they pick them at random. Okay, but if they're just in the box and there's, like the Russell Stover, there's usually like a key on the bottom of the box. It's like in this spot it's this, and this spot it's. Okay, well, let's hypothetically say this one doesn't have that. Okay, you can still pick at random out of the box, and either it could be like you picked every other one or something like that, just the way that it works out. And like maybe every other one is vanilla, or maybe like everyone down this column is vanilla, and you just went down thinking, oh, every column's going to be different or whatever, like however it falls. So like there is a hypothetical possibility of that. So one thing that we typically will look at is we're going to have alpha levels. And alpha can either be 0.1, alpha can be 0.05, or alpha can be 0.01. So basically 10%, 5%, or 1%. So there is basically these are a threshold where we decide to reject or not reject the null. So, because I have noted that my p-value is not too low, it is possible there are 6 vanilla and 6 peanut butter. I'm just going to do PB for peanut butter. So basically, my alpha, typically 0.05 is where we're going to set alpha. It can be all the way out to 0.1, but it has to be like lower than that number, whatever we decide. So if I chose an alpha of 0.05, this is not too low, and so it is possible. So let's say then that we eat a fourth one and it's still vanilla. All right. What is the probability of that? Well, we would take this 120 out of 1320 and we would multiply this, and I'm just using the numbers because we've already done that, times what's the probability that the third one is vanilla?
3 out of 9.
Yep, so times 3 out of 9. So I take that number that I had and multiply it by 3 over 9. So this gives me 0.03, and it would just be a 0. So if that happens, and I've chosen an alpha level of 0.05, this is less than that now. So the p-value, so it's more readable. P-value is low, so we reject the null hypothesis, and I usually just write H sub 0 for that. That there are 6 vanilla and 6 peanut butter. And then I would just say something like, it is possible that there are more than 6 vanilla. So obviously on this one, we didn't actually write the hypothesis, but they essentially told us that there's 6 vanilla and 6 peanut butter, so the null would have been that it's equal to 0.5. The alternate would have been that there are more than 0.5 if we had done that, but that wasn't what this question was asking for, so. Let's see. A survey investigating whether the proportion of today's high school seniors own cars is higher than it was a decade ago and finds a p-value of 0.017. Is it reasonable to conclude that more high schoolers have cars? Explain. So the null was what we do first. And this one's going to be done in words. Basically, just because they don't really give us enough information to do the other stuff, would be that the percent of high schoolers, and I'm just going to do HS for high schoolers, who own cars has not changed. Because remember, the null is always that there's no change, so it's exactly the same. The alternate would be that it says higher than So this would be a greater than if we were doing it, but we're doing it in words, so this would just be that the percent is higher. So now we're looking at this p-value that they gave us. A kind of safe assumption is that we're going to go with an alpha level of 0.05 unless they tell us otherwise. Like they will specify at an alpha level of blah, 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 like whatever, like, and then they'll ask you the question. If they don't tell us, we're going to assume 0.05. Pretty safe assumption. So we would say that the p-value is low because this is less than 0.05, and we could just say 0.017 is less than 0.05 so that we know what alpha level we're looking at. So we reject the null hypothesis. Meaning there is enough evidence to conclude the percent has risen. All right, so on to, not that button. The next one here, we may not get all the way through it, but we'll get through as much as we can. In the 1980s, it was generally believed that congenital abnormalities affected about 5% of the nation's children. Some people believe that the increase in the number of chemicals in the environment has led to an increase in the incidence of abnormality. It's pretty interesting because this is kind of all coming back around now. People are making a big deal about things that are banned in other countries, and anyways, I'm not going to get off on that tangent. But a recent study examined 384 children and found that 46 of them showed signs of an abnormality. Is this strong evidence that the risk has increased? All right, so key word is increased. Okay, so my null is going to be that it's equal to 0.05, so no change. So P equals 0.05. I guess I should write H sub 0 here. So P is what? Then 0.05 for the alternate based on what it says. Based on this word right here. Yep, greater than, because it says it's increased. So just because we're going to be looking at this later, this, as a refresher, is a right tail test. Just to keep that in mind as a refresher also. So check the conditions. Is this random? I would say yes, because we don't know where they're, I mean, yeah, it has to be random, so if it's not random, it's definitely representative, so it's just safe assumption. 10% condition are 384 children, less than 10% of all children.
Yes.
And success failure, both of these numbers going to be greater than 10.
Yes.
Yeah, so we're good to go there. So all the conditions have been met, so I'm good to go. So my P hat is this 46 out of 384 because we're looking for this specific situation. So 46 out of 384, which is that's annoying, 0.12, because it's 0.1197, so rounding it ends up being 0.12. I was going to go to 3 decimals, but 3 decimals would just give me a 0 at the end. So anyways, there's that. Then the standard deviation is p hat q hat over n and all into the square root. So 0.05 times 0.95 divided by 384. And that gives me 0.011. So I could at this point find the z-score, but since I'm going to use the calculator function, I don't really need to do that. So we use one prop z-test. It'll be of 0.05, which is the p-value, 46, 384, and then it's greater than p0. So stat test, one prop z test, 0.05, x is 46, and remember x always has to be a whole number. I'm just going to reiterate that because that ends up being a problem most often out of everything. And we're greater than, so then we calculate it. So they tell us that, 1, they give us z, but 2, the p-value is equal to 1.75 times 10 to the negative 10. What does that mean p is approximately equal to? 0. So p is approximately 0. Which means what? What does a p-value of 0 mean?
It can't happen.
It's super duper low. All right, so that was real mathematical there.
Super.
Super low.
So explain carefully what the p-value means in context. This means that if 5% of kids have birth defects,
That's a lot of kids.
the probability my sample has 12%, or I guess I should say approximately 12%, because that's the p hat that I got was 12, is 0. So the conclusion specifically for this problem is that my p-value is low to the point that it's even lower than an acceptable alpha level of 0.01. So basically it's lower than any reasonable alpha. Or alpha level. So we reject the null hypothesis, meaning there is enough evidence to suggest the rate has increased. So remember, if the p-value is high, we fail to reject, and there is not enough evidence, because fail to reject is 3 words, and there is not enough is 3 words. So that's how we keep those straight. So basically, do environmental chemicals cause abnormalities? Correlation does not equal causation, so we can't say for sure. Without running a controlled experiment but it is possible. So eventually we're going to get into some stuff where we're going to say it's possible but not probable and things like that. But for right now, it is possible, but basically, in short, correlation doesn't equal causation. So just because we see this doesn't mean that it's an environment that's causing the problems.